What we're going to get into next is a binomial probability. And the reason why we call this a binomial probability is because we can set it up as a binomial of P plus Q. And the reason why we use P's and Q's is because, how do I want to phrase it? Is because P is a probability, and the thought process with a binomial is it's basically two situations. Like P, we have what's called a success, and Q is what we would call a failure. And the thought process, and you'll see it in the notes here, that P plus Q, well, you either succeed or you fail, so the sum of those two is 1. And what we're going to do is take it to some power, but think about it, 1 to any power is still equal to 1. That's why this works. So in our first example, to set you up with this, is we're flipping a coin or rolling a 6-sided die. I feel like we've done something like this before. I know this says ordered pairs. I kind of like the thought process on just writing out. You can get a heads 1, a heads and rolling it 2. Heads 3, heads 4, and you can write these as ordered pairs if you feel inclined to. I just kind of like it this way instead. Every math teacher is a little bit different. Tails 1, tails 2, tails 3. I'm writing a lot larger here. Tails 5 and tails 6. But we're not really caring that we have 12 options. But what they're asking you for part B is determine the probability of getting a heads and a number less than 3. Now the way I'm thinking of this is that it's not equal to 3. So what I would do is identify that we have 2 options out of 12. So our probability would be 1 out of 6. And again, you can change that to a decimal, percent, whatever you feel like. Now, if we look at the individual probabilities of getting ahead and getting a number less than 3, so just the probability of getting ahead would be 1/2, because if you look at all of them, you still have 6 out of 12, which still reduces to 1/2, and then probability of getting a number, all right, and less than 3, is still going to be 2 out of 6, or 1/3. And even if you said, well, what about 4 out of 12? Sure, that still reduces. And so what they're trying to get you to think about is a different way of getting this answer is, okay, well, if we look at the 1/2 and we look at the 1/3, is there a way I can do an operation to those two things and get 1/6? And that answer is sure, you could have multiplied. And what we do is we call this the probability of being independent events. That getting ahead had nothing to do with rolling the 6-sided die. And so they're independent of each other. One event does not depend on the outcome of the other. And so what we can do with this situation, just like the fundamental counting principle, is multiply those events together. So that's why this works. So I'll write that out. We can multiply. If you're confused on independent events, please bring that question to class and maybe we could have a discussion on what makes 2 events independent. And they're bringing that idea to you to help you understand the binomial probability problems. And we use them a lot of times when we have these success and failure problems. So that's exactly what's happening on exercise 2. We have a 5-question multiple choice test. Each question has 4 choices. So that's what I mean by a p-value, a probability of success. P being a success. Well, in this problem, you have a 1 in 4 probability of being correct. That means Q, in my example, would be a failure. So your probability of a failure is 3/4. So when they asked you to find the probability of getting exactly 3 out of the 5 questions correct, what they want you to do is think about, okay, well, I want to succeed. We want 3 of them to be correct. Let me change colors just to emphasize where I'm getting this 3 from. And what that means is I need to fail So the other two situations, if I have 5 questions and I have 3 of them were correct, I need to fail twice. Need to fail twice. Now the problem with just multiplying these two things together is this looks like I'm succeeding the first 3 times and then I'm failing the next 2. But that's not the only way to do that. So let me write it that way, like P for success, 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 and then fail, fail. But what I could have done is succeeded and then failed, succeeded and then failed. Or I could have succeeded, succeeded, failed, failed. Forgot how to write a Q, I guess, and then succeeded. And there's several ways of doing that. Well, let's think about it. The reason that how many different ways could we have succeeded and failed? Well, out of the 5 problems, I needed to succeed 3 times. It's a 5 combination 3. In other words, let's use a calculator just because I feel like it. There were 10 different ways I could have gotten exactly 3 questions correct. And so we multiplied the 10, how many different ways we could have done it, by this answer. It would be 1 over 64, and then 3 squared is 9 over 16. And you're welcome to use a calculator. There's nothing wrong with using a calculator. Since I already did some of the things, I'm just going to go ahead and type it out. That our probability would be 45 out of 512, which comes out to be about an 8.8% chance of just randomly guessing and getting exactly 3 correct. Now, I'm trying to keep this video sort of short, but the summary of what I just did is written right here. And I kind of wish they started without getting exactly 3 correct, because I don't know if you would have thought about some of these other things. But again, feel free to pause the video or re-watch things and then bring questions to class. So we're practicing the same thing. They say the probability of rain on a given day, and whatever this is 2/3. So we're going to consider the probability of getting rain. That's going to be your success. And so the failure would be not rain, which kind of sounds weird, but that's okay, would be 1/3. And that's where they get this phrase from, that the 2 of those success plus the failure has to equal 1. So what's the probability that it will rain on exactly 5 of the 7 days? Okay, so we have 7 days. Combination, we want rain 5 of them. And then your probability of 2/3, we want to succeed 5 times, but we want to fail twice. And you can actually go straight to your calculator and type that in just the way it looks, and it'll spit out the correct answer. 7, I did a permutation again. 7C5. You can even write it as a fraction. Your calculator knows as long as you type it in correctly. And remember, your probability should be a number smaller than 1. So if you ever get an answer that's bigger than 1, you know you did something wrong. Smaller than 1, and you can change it to a decimal. And remember, some of the answers will want you to write it as a percent. Some of them want it as a reduced fraction. So get used to these calculators. I'm going to change it to a percent just for that. So what about the probability it will rain on exactly 1 out of the 7 days? So not very likely. So 7, combination 1, we want the probability of rain to be exactly once, and then we want it to not rain 6 times. Again, if I'm going too fast, you might just want to write down your questions and bring them to class. But what I like so much about this is I could go back to things I've already typed in and just change a few pieces to it. And then change that fraction to a decimal. Maybe the stats teacher in me really likes a decimal over the fraction. and then move that decimal over twice. Very not likely that this very rainy place only would rain once in a 7-day span. Another situation where we're trying to get exactly 4 heads when flipping a fair coin 8 times. So what you have to do is think about the probability that you get 1 head. So the probability of a success in this problem would be 0.5. And of the 8 times we flip the coin, we want exactly 4 of them. Success being 0.5, 4 of them. But that means we need to fail 4 times as well. And you don't have to write it that way. You could change 0.5 to be a fraction. 8C4. I don't know if I have to hit times. I'm going to go ahead and hit times. 0.5 to the 4th power times 0.5 to the 4th power. And you give your probability. This time I get the decimal because I typed it in as decimals. You will then need to go back and change things to a fraction. So if you hit that math key, over to a fraction. And if any of you want the help on how to do this by hand, I can show you that as well. And maybe in class I spend a little bit more time showing you how to do it without a calculator. The next problem is talking about this really good basketball shooter, or free throw shooter. I don't know if you think 80% is pretty good. But anyway, if she shoots 6 free throws in a given game, what's the closest to the probability that she'll make exactly 4 of those 6? So that would be 6 combination 4. I'm just thinking out loud that if she's an 80% free throw shooter, we want to make it as 0.8. That's the probability of success. So we want her to succeed exactly 4 times, which means she has to fail exactly twice. And you can see there's a lot of using a calculator. I said 0.2. We said we wanted her to fail twice. That sounds like a negative thing, but that's how we think in math. And then 0.8 is her probability of success. And we wanted 6C. Okay, hopefully I copied that down correctly because this is in my way. 6C4, 0.8 to the 4th, 0.2 to the 2nd. There we go. About 25%. And then we have one more. And this time, let me make sure. And that's the thing is you have to be careful because this says exactly 4. And hopefully I haven't missed anything here. But we have a good hitter. We'll get a hit about 1/3 of the times he comes up to bat. What's the probability that we'll get a hit each time if he bats 4 times in a game? So we have 4 at-bats, and we want to hit each time. So what that means is the 1/3 would be taken to the 4th power. Now let's think about it for a second. Is then the failure would be to the 0 power. Now don't freak out, because when you see that 0 power, remember anything to the 0 power is equal to 1. And 4 combination 4, if you remember our tricks on doing these combinations, that something divided by itself is equal to 1. And 0 factorial is equal to 1. So I hope it would make sense, if you're looking at this, that we want a success each time, that there's only one way to get a success each time, and that would be 1/3 to the 4th power, which would get us to option 3. And again, feel free to use a calculator on that. Again, feel free to re-watch the video, bring questions to class, but you should be ready for this homework assignment.